Okay, you know the moment. The interview's going great, you're feeling confident, and then the hiring manager leans back and hits you with one of those big, open-ended questions. Well, today we are tackling one of the biggest, database management. And by the time we're done here, you're going to have a complete playbook to turn that high-pressure moment into your time to absolutely shine. So picture it, you're in the hot seat and they drop this question on you. It's broad, it's a little intimidating, and it's your big chance to either really impress them or totally stumble. See, this isn't just about listing a few buzzwords. It's about showing you have a real strategy, a whole philosophy for handling data. So where do you even start? You start right here. This sentence, this is your opening move. It's confident, it's comprehensive, and it immediately tells the interviewer, hey, I'm not just a coder, I'm a strategist. This one line sets the stage perfectly and gives you a roadmap for everything you're about to say next. All right, so how do we build on that killer opening? Here's our game plan. We'll start with the core pillars of database management. Then we'll dive into the juicy details, comparing SQL and MongoDB on things like schemas and performance. We'll cover the non-negotiables, like security and recovery, and then we'll bring it all together to craft that perfect winning answer. A really great answer, it isn't about some single magic bullet. It's about showing a holistic view. It's built on the strategic framework of core principles. So let's actually break down what these pillars are. So these 8 pillars, this is basically the interviewer's secret checklist. They're listening to see if you think about the whole life cycle, from the very beginning with data modeling all the way through to security, backups, and monitoring. Now for our answer today, we're going to focus on the big 3 that really move the needle: how you structure the data, how you make it fly, and how you keep it safe. First up, data modeling. Seriously, how you structure your data is the foundation for everything else. It's going to dictate your performance, your flexibility, even your data integrity. And the way you approach it is totally different between a classic SQL database and a NoSQL one like Mongo. Okay, what's so cool here is the difference in philosophy. With SQL, the whole game is about having a single source of truth. You normalize everything to avoid duplicating data, and you link tables with keys. But with MongoDB, you design for what your application actually does. If your app always grabs order items with the order, well, you just embed them right inside the order document. It's all about making reads super fast by avoiding those complex joins. Let's be real. Performance is where the rubber meets the road. I mean, a slow database means a slow app, and that means unhappy users. End of story. This is where you get to move past the theory and show you know how to get real-world results. If you only remember one thing about performance, make it this: indexing. An index is basically like the index at the back of a textbook. Instead of the database having to scan every single page, or in this case, every single row to find what it's looking for, it can just jump straight to the right spot. It is, without a doubt, the most effective way to speed things up. In SQL, it's a pretty straightforward command. You're just telling the database, hey, I'm going to be looking up users by their email a lot, so please create a shortcut to make that search basically instantaneous. And hey, look at that. In MongoDB, it's a really similar idea, just with a different syntax. You're telling the user's collection to create an index on the email field. That little one just means it's an ascending index. The goal is exactly the same: pure speed. So beyond indexing, the way you actually write your queries is huge. In the SQL world, avoiding select star is like day one stuff. You only ask for the data you actually need. In MongoDB, the same idea is called a projection, but the principle is identical. The less data you have to move over the network and process in your app, the faster everything is going to be. So what happens when your app blows up and gets super popular? Well, this shows the 2 different paths. SQL databases traditionally scale up, or vertically. You just buy a bigger, beefier server with more CPU and RAM. MongoDB, on the other hand, was built to scale out, or horizontally. You just add more, cheaper servers and spread the data across them. It's a process called sharding. So we've made our database fast. That's great. But speed means absolutely nothing if your data isn't safe or if it could be lost forever. Security and recovery, these aren't just nice-to-have features. They are the absolute bedrock of good database management. The good news is, the best security practices are pretty much universal. You always want to give users the absolute minimum permissions they need to do their job. That's role-based access control. You encrypt everything, everywhere. And you never, ever, ever expose a database directly to the public internet. Oh, and using parameterized queries, that is your #1 defense against SQL injection attacks. Super crucial. And what about recovery? The strategy here is simple, but so critical. Your backups have to be automated. You need the ability to restore to a very specific moment in time, not just yesterday. And here's the kicker. You have to test your restores regularly. Because a backup you've never tested, that's not a plan, that's just a hope. Okay, now let's tie this all together with a story. Theory is good, but a real-world win is interview gold. You frame it just like this. This reminds me of a project where our MongoDB queries were really lagging. So my first step was to use the explain command to see what was actually going on under the hood. And it turned out we were missing a few key compound indexes. So after adding those and tweaking the document structure, the result was a performance boost of over 40%. See, putting a hard number on it makes your story totally concrete. It makes your impact undeniable. It shows you don't just fix problems, you measure your success. This is what separates a good answer from a great one. So we have covered the framework, the nitty-gritty technical details, the comparisons, and the real-world story. Now let's put it all together into that final polished winning answer. And to really stick the landing, you use this as your closing statement. It circles right back to your confident opening, but now every one of those phrases is backed up by concrete examples you've just given. It's the final, polished summary that's going to leave a really strong impression. And let's be super clear about why this whole strategy is so powerful. This table right here, this is the magic. While you're talking, the interviewer has this mental checklist by telling a real story, by talking about indexing, by comparing SQL and NoSQL, and by discussing scalability. You're not just answering their question. You are literally demonstrating the exact qualities they are looking for. And there you have it. That is how you ace the database management question. But at the end of the day, just remember this. Effective database management isn't really about managing rows in a table or documents in a collection. It's about enabling the application, it's about serving the user, and it's about solving a real business problem. The absolute best answer shows you don't just understand the how, you also understand the why.